All right, let's take a look at our lesson for today. It's derivatives of inverse trig functions. Now, last time we did inverse functions, which is an interesting topic for sure. We're going to focus this time on just inverse trig functions, our, arcsine, arctangent, so forth. And yes, you get to memorize more formulas. Oh, so exciting. I know, you're like, yay! Dr. Wright, how exciting. Okay, so here we go. Again, what I like to do is I like to kind of walk through and show you how I memorize them. Maybe that'll help you. I pair them together. So they actually are, these are identical, except, and what do we know about trig functions that start with a C? What are their derivatives? Negative. And all of these, notice all of these C functions are negative. They're an exact duplicate of, so sine and cosine are exact duplicates of each other. It's just the arc cosine one is negative. Okay? Likewise with arctangent, arctangent and arccotangent are exactly the same, but arccotangent is the negative version. And lastly, arcsecant and arccosecant are exactly the same formulas, but arccosecant is negative. So that's one pattern that I want to talk to you about. Another pattern has to do with the radicals. So if we look, we see that arcsine has a radical in the denominator, and arcsecant does. Okay, they do. Notice they both have radicals. One of them is 1 minus x squared. The other one is x squared minus 1. And that's something that I've found historically students have a little bit of trouble with. And several years ago, one of my students said, well, you know how I remember? They were like, I remember because these x's are right next to each other. And so that makes me remember that it's the arcsecant that x squared minus 1. And the arcsine is 1 minus x squared. That's how they remembered the order to put them in, because one is 1 minus x squared, one is x squared minus 1. The arctangent doesn't have a radical at all. So I want to pause here for a second. Any questions on the formulas themselves? Okay. So what I would like to do is talk about, this actually is from pre-cal. Some like to put the information in this form. I think your book does. That's the form they like to put it in. What I prefer is to put it in a unit circle form instead of going through all that. I want to talk to you about, because this is important. The domains of inverse trig functions is important. And you may or may not remember the principal value. Do you remember that word, principal value? Not really? Okay. Well, let's talk about it. So we're just going to do a coordinate plane. These are for the arc functions. This is for inverse trig. And you really need to have this information like in your brain, memorized, so that you don't make a mistake about an angle. So let's talk about it. So for positive, I'm just going to put this in. So for positive, if this x value is positive, okay, this is what we're talking about, these x values right here. If the x value is positive, then the angle measure is going to be in the first quadrant, period, all six. All six. If this measure, so let's remind ourselves about inverse. What do we know? So sine of x, so y equals sine of x, right? That's what we know. We know that for arcsine, this x, the x's and the y's switch, right? That's what we know. That's what we know about inverses. The x's and the y's switch. So if I am finding sine of pi over 6, Sine of pi over 6 is 1/2, right? Unit circle value. And arc sine of 1/2 is pi over 6. See how the x's and the y's switch? Okay, so that's a thing. So what we're doing is we're setting up where we get these numbers from, these angle measures. Where do they come from? Which quadrant do we have? We don't have a choice. We do not have a choice. Which quadrant do we go to has to do with this, this coordinate plane that I'm drawing down here. That's what it has to do with. So let's talk through it. And this is pre-cal. So all 6, if that x value is positive, all 6 angles will come from the first quadrant. If the x value is negative, then it splits into 2 different sections. So for quadrant 2, what's there? In quadrant 2, we've got, for negative, we have arc cosine, its reciprocal, arc secant, and arc cotangent. If that x value is negative, that is where you're going to get your angle measure. You're going to get your angle measure from the second quadrant, period. And you have to go this way to get to it. It's the positive. You've got to go that way. If that x value is negative, then you have to go to the fourth quadrant for arc sine of x, its reciprocal, which is arc cosecant of x, and arc tangent of x. And to get to this angle measure, you have to go backwards. There is no choice. All of the angle measures in the fourth quadrant must be represented as negative angle measures. Let's write that down. All angle measures in Q4 must be negative. Negative angle measures. That's because of inverse trig. Okay? And this section right here is nothing. Nothing. You're not allowed to pass through it at all. You can't go all the way around to get here. That's not a thing. That's just nothing for inverse trig. This is called principal values. If I could spell. Principal values. Okay, I'm going to pause here for a second. What questions do we have?
In Q2, they're all negative.
All the x's are negative. If the x that I have, like this x right here, is negative, and it's an arc cosine, arc secant, or arc cotangent, then I have to use quadrant 2. But those angle measures are positive. The x value is negative, but the angle measures are positive.
What's the angle measure?
Okay, so like up here. So like if I said, what is, actually we're going to do some examples that what I'm talking about. I'm talking about this is the angle measure, that pi over 6. That's an angle measure, right? That's in radians. That's what I'm talking about.
So it says like,
So
negative. Cosine.
So if the, okay, so these x values right here, these x values refer to this negative. If those x values are negative, the angle measure is from the second quadrant. But the angle measure is positive. Okay, the angle measure is positive. And we're going to do some examples of that just to remind you. Okay, any other questions? Okay, so let's do some examples. First of all, if you could, had a typo. Look at number 3 and 2 and 3. I don't know, it didn't get changed properly. So if you would please, if you would adjust your slide so it looks like this. So number 2 is actually arc tangent of x at x equals -1. And number 3 is arc cosine of x at x equals -√3/2. That would be great. And this, we're still doing pre-cal right now. We haven't started calculus yet. It's just pre-cal. Okay, this is an example of what I was just talking about with principal values. They want us to evaluate each function at the given x value. So, okay, we can do that. That's not a problem. All right, so let's look. So this is arcsine, and the x value is negative. Look back at our chart that we just did. What happens when arcsine has a negative x value? Which quadrant are we supposed to go to? Quadrant 4. So because of this, we are in quadrant 4. I'm just going to make a note. You should make a note because this is where the mistakes happen. This is going to be in quadrant 4. And we have to rotate backwards to get to it. Quadrant 4 angle measures. Okay, we've got to rotate backwards. So we need to think to ourselves, what angle measure in quadrant 4, now because we're going backwards, would sine be -√3/2? So -√3/2, if you recall from your unit circle, which we do all the time, right? Unit circles all the time. √3/2 is larger than 1/2, so this is this angle measure right here. It's the one that's longer along the y-axis. It's this one. And remember, we count. So this is 1 pi over 6, 2 pi over 6. So this would be a -2 pi over 6, which is a -pi over 3. So the answer to this, arcsine, so we'll just write out arcsine of -√3/2 is -pi over 3. That's my answer. Now, are there other places where arcsine is -√3/2? Sure. But they're not principal values and we're not allowed to use them. This is another location where arcsine would be -√3/2. In the third quadrant, well, we're not allowed to use that for principal values. That's not okay. So that's the whole deal with, see all these restrictions that they gave us in this kind of form? That's the whole point of all of this, is to tell you that your answer is restricted. Your answer is restricted. And the x's and the y's have flipped from the regular trig function. Okay. Are we okay with that? Yes? Okay. Number 2. Arctangent of -1. Looking at our little drawing here, what quadrant should arctangent be when x is -1? Quadrant 4. This should be quadrant 4. Okay, so let's just make ourselves a note so we don't make a mistake. Because this is negative, this should be quadrant 4. Okay, so I'm going to draw mine, because that's what I like to do. So tangent being 1, that's at all the 45/45s, right? 45/45 90s? That's where that tangent is 1, or -1, depending. And I got to go backwards to get there. I have to go backwards because I'm in quadrant 4. So what angle measure would that be? Absolutely, -pi over 4. So arctangent of -1 is -pi over 4. Now, you probably remember from pre-cal, there are an infinite number of ways I can get to this location, right? I could have gone all the way through and have been 1, 2, 3, 4, 5, 6, 7 pi over 4. But no, I can't because I'm not allowed to do that. For principal values, I'm not allowed to do that. There's only one answer that's acceptable for each question instead of an infinite answers being acceptable. Okay, is we okay? Okay, so let's look at number 3. Arc cosine. Okay, so where is arc, which quadrant is arc cosine negative in? 2. So we need to be in quadrant 2. Okay, so let's draw this quadrant 2. Let's see, x, so root 3 over 2 it's longer along the x, so that's this angle measure. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. It's 5 pi over 6. Okay, so arc cosine of negative root 3 over 2 equals 5 pi over 6.
I thought it's supposed to be longer than the y-axis. Or the root 2.
So cosine is for the x, right? And root 3 over 2 is bigger than 1/2. So when it's longer along the x, that's the root 3 over 2. Is that okay? Okay. How are we doing? Okay, so that's a pre-cal review. That's going to help you with the work that you're doing, that you will be doing. But this is not the calculus yet. All right, so the first thing, again, this also is pre-cal, the simplifying. We're just going to practice simplifying this. That's all, just practice simplifying. So let's see. I can't really do anything under here, but I can work with this stuff out here. I can work with that. We know the square, the absolute value of 3 is just 3, right? Absolute value of 3 is 3. So I can do simplify 9/3, right? And that would leave a 3 right here. Okay, so let's just start this. I can't do anything with that, so I'm just going to write it down. Okay. So now I need to deal with, let's pull it out over here, x squared over x cubed. And I know that's absolute value, but I'm just talking about the exponent. So if I ignored the absolute value for just a moment, could I simplify this? X squared, I could, couldn't I? What would this turn out to be? 1 over x, right? 1 over x, because I got 2 on the top, 3 on the bottom, it leaves me 1 on the bottom. So this one stays on the bottom, and I have to keep the absolute values around it. And that's all I can do to simplify. And so we're doing this because in just a minute, we're going to do calculus, where we can get something like this, and we have to know how to simplify it. Okay, are we okay? All right, so that is prepping us for our calculus. Okay. So let's take a look. This one. At the actual calculus. Okay, here we go. So the trig, arc functions, the inverse trig functions, sometimes really freak students out, but really it's much easier to take derivatives of them because all we're doing is using a template. All these little formulas up here, all these formulas, we just have to memorize them as the template. That's it. Okay, they're a template. So we're looking at our first example. We've got arcsine. So I'm going to write the template up there. Arcsine is 1 over square root of 1 minus something squared. And if that something is anything other than x, what do I have to do? Chain it. Yes. Very good. Chain it. I have to chain it, which I'm going to write right here. I have to chain it, right? Okay. So what am I going to put there? I'm going to put this thing right there. That's where it goes. I mean, whatever's in there, it doesn't matter. Whatever's in there, we just plop it right there. Okay, so I'm going to put that there. And that is not just an x, so I have to chain it. What is the derivative of 3x? 3. And that's the calculus. Now we just need to pretty it up with algebra. Okay, that's the calculus. You just write the template down, you plug stuff in it, chain it, done. All right, so let's pretty it up. So that's going to be 3 over square root of 1 minus. What would 3x squared simplify to be? Very nice, 9x squared. Very nice. All right, and that's our first derivative. That's not too bad, right? It's really not too bad. You just have to memorize the formulas. Okay, so arctangent. Does anybody, I know you just seen them, do we know what that formula is? Somebody tell me. Is it 1 over, what's the formula? 1 over 1 plus x squared. Okay, something squared. Okay, so again, this is our something. It goes right there. Is that just an x? Nope. So I'm going to have to chain it. And what is the derivative of 2x squared? 4x. Okay, the calculus is done. Now we're just got to pretty it up with algebra. Okay, so I'm going to put the 4x up there in the numerator. I got 1 plus. What is 2x squared going to turn into? Very nice, 4x to the fourth. And we're done. Okay, wasn't the pre-cal part harder than the calculus part? It was, right? That pre-cal part was a lot harder than this. All you got to do is memorize the templates. One more. Derivative of arcsecant. We need its template. It's 1 over what? Very nice. Absolute value of, we're just going to leave this open, absolute value of something times the square root of something squared minus 1. Beautiful. And our something looks like this, and our something goes both of those places. Both of them. Okay, so I just put a 5x here, I put a 5x here, and is 5x just an x? No, it is not, so I have to chain it. And what is the derivative of 5x? 5. Okay, calculus is over. Now we're just cleaning it up. So I've got 5 over, let's see, absolute value of 5x, square root of, what is 5x squared, 5x all squared going to turn into? 25x squared, very nice. And that is it. Ah, yes, actually you can, because very, very good catch, good catch. So absolute value of 5 is just 5, and 5 over 5 is 1. So yeah, let's do one more prettying step. So it looks like this. X squared minus 1. All right. There we go. We doing okay?